innovative optical wireless network global forum, and also LFH on the photonic disaggregated computer, which is the new concept for the computing architectures. Let me just start by introduction myself. My name is Harushi Safukano. I'm working for the Fujitsu about the business and architecture, planning about the 6G era infrastructure. I have more than 10 years of experience in the research and development about the heterogeneous computing, and also my job is FPGA design for the network equipment. About activity in the open community, I joined the Linux Foundation Edge from the 2020, and I become a Technical Advisory Council member from this year, and also LFH Arduino project. I am the TSC co-chair from the 2023. In Arduino, we contributed OSS stack for the building sensor network for the robotics. Let me explain about the outline of today's presentations. Firstly, I would like to introduce LFH and also Arduino project as LFH members. Next, I will talk about the computing challenges, including the edge area. And then I'd like to introduce about the idea and activity to solve these challenges. And I will explain the photonic disaggregated computer as proposed by the ION Global Forum, which is a key to solve the challenges. And also LFH and ION started the joint proof of concept using the photonic disaggregated computer. I will explain about this. And finally, I would like to introduce our upcoming schedule. So let me introduce to the LFH and the Arduino project. Here is the LFH overview. LFH is an umbrella organization for the edge computing under Linux Foundation. The goal of the LFH is to create an open source framework for the edge computing. As an umbrella organization, we have several projects under the LFH. As you can see, the project is divided into the three stages, from the at-large stage, growth stage, and also impacted stage. Impact stage means which is market release phases. Each project has its own technical steering committee, which decides its management policy and operate independently. So Arduino is the impact stage, and also HREC and InfiniEdge AI, which host this event, is at the large stages. It starts from this year, the new upcoming project. And also, there are more than 30 sponsors in total. Fujitsu is one of the premier members from the 2019. And next, I'd like to briefly describe each LFH project. There are a wide range of edges, including the area code for user edge and also service provider edge. And also, there is a layer about the from the infrastructure layer to the application layer. The LFH project covered all wide range area user edge to the service provider edge, and also application layer to the infrastructure layer. In particular, Acreno aimed to develop and publish the edge use cases and the OSS stack, which achieve the use cases. And also, Acreno is a wide range of the area from the user edge to the provider edge, and also infrastructure layer to the application layer. For this reason, we Fujitsu has been working in that layer for several years. This slide explains about the LFH Acreno. LFH Acreno is developing and publishing the edge computing use cases and OSS stack for the as a blueprint to implement edge computing more easily. As shown in this picture, Acreno blueprint is the OSS stack, use case basis, fully integrated end-to-end solutions, and also proven and tested by the communities. So using this blueprint brings users to reduce the cost and also large scale and integrated as a few effort, for example, zero-touch provisioning, and also can be deployed on the open hardware and other benefits. So Acreno published over 30 blueprints across a wide range of the area, from to the user edge to the service provider edge, and also infrastructure layer to the application layer. If you have an edge use cases or ideas, we can help you open it on the Acreno. So feel free to ask us about it. So next, let me get down to the main topics. I'd like to talk about the challenges in the computing for the 2030 LF. As first, these figures show you evolution of the AI model. The vertical is the amount of the flops required to train each AI model. And also, horizontal is the year of the publication for each AI model. As you can see, flops of the AI model is growing at a rapid rate of amount 23 times per year due to the generative AI evolutions. This is much faster than the speed of semiconductor evolution. We call the Moore's law. So we are holding on that speed by increasing the number of the power GPUs and CPUs and making the system larger and larger. So I think this will eventually bring us to a power consumption collapse. So I say the power GPUs and also power CPUs. And another idea is that the system should be tuned for an AI model using the specific accelerators and also specific circuit. But as the diagram on this slide shows, the resource requirement for the AI model different for each model. For example, the phase of learning and inference, other other AI use cases, for example, ranking and recommendations, and also inference training. So I think coexistence of the reducing power consumption and the flexibility is the challenges in computing for the 2030s. To solve these issues, the Linux Foundations and also ION Global Forum has signed a master agreement. The ION Global Forum stands for the Innovative Optical and Wireless Network. They are working for the innovations and implementation of the new network and computing infrastructure for 2030s. Regarding ION Global Forum, MTT, who is Japanese biggest telecom provider, Harada-san will explain more detail in the evening session. So LF and ION Global Forum will integrate Linux Foundation software with the ION Global Forum network and computing platform to enable higher performance and low latency and energy efficiency to meet growing the data delivery demand. In this slide, I will introduce the ION Global Forum and the LFH joint work, which we propose as a specific initiative for the ION Global Forum and LF collaborations. As shown in this figure, the ION Global Forum has a use case working group that define future use cases, and also a technical working group that consider the technology required to implement these use cases. And also LFH has use cases and also Acreno have use cases and OSS stack to achieve that. And the use cases, there is many common use cases between the ION Global Forum and LFH. For example, the cyber-physical systems. So based on these common use cases, we started to integrate it, LFH OSS stack on the ION Global Forum infrastructure to prove the affinity between each technology, power, efficiency, and flexibility. Before I explain more detail about LFH and the ION Global Forum joint work, let me explain about the photonic disaggregated computer, which is a key technology to improve computing performance and efficiency. And this is proposed by the ION Global Forum. In this slide, I will introduce photonic disaggregated computer. This photonic disaggregated computer has two features that very different from the existing computing architectures. The first is disaggregations. This allows for us for flexible device allocation and reallocation using such PCI fabric switches. The second is to communicate the data directly between the accelerated devices via the photonics connections. As shown in this figure, the users request resources depends on their applications. Then the controller of the photonics disaggregated computer issued instruction to the CDI management software. The CDI management software which manage the resource pool and also allocate resource to the user and configure the logical node. Depends on the use cases. There also controller set the optical switches to configure a direct connection between the accelerator devices. So I'd like to talk about the more detail about the photonic disaggregated computers features. First is disaggregations. This allows for flexible device reallocations and also allocation. For example, if each applications require different resources in this figure, the current computing is server oriented. So we will allocate resources to each applications on the server basis. So this may leave some device unused resources. As a result, utilization efficiency is reduced. On the other hand, this is a disaggregation. We will allocate minimal resources from the resource pools which comes from the PCI switches, so we can optimize resource utilization. Second is device to device connection via the photonic connections. As this figure shows, the left one is client CPU-centric architectures. Data is transferred between the such as accelerator devices by the CPU through the CPU memories. So this causes CPUs tend to be a performance bottleneck. On the other hand, the case of the device-to-device direct connection using the photonic connections, the data is transferred between these accelerators via the shared memory or connected by the PCIe fabric switches and also directly. So this will reduce the CPU load and the current used for the data transfers, thereby reducing cost and power consumption. And also, I think processing delay we can reduce. And next, let me explain about the ION Global Forum and LFH joint box detail. Now we are looking for use cases to maximize the synergy between the ION Global Forum and the LFH. So first one is generative AI plus robotics. There is many challenges for the current robotics. Current robots perform certain action in the certain environments, but the future robots will be required to perform various actions in different environments. For example, collaborate with a human in the same place. But it is difficult to design and to build a program teaching to the robot, assuming a different environments and the various operations. So teaching to the robot will be a big challenge for us. So we think generative AI plus robotics is the solutions. When robots receive the command or operations that it does not know, generative AI asks to the generative AI, and the generative AI generates the animations regarding the command and the operation, and then from the animations convert the animation to the robot teaching data, such as the arm trajectories. And also the result of the robotics motions, we will capture the data and also correct it as a training data of the generative AI. So generative AI, we will implement in the cloud area, and also robotics. Robotics will be the edge node area. This is the overall architecture about these use cases, ideas using the ION and LFH technology. At the edge area, we collect the data and store data using the Grand Robotics Blueprint and also HX Foundry framework. And also LFH Edge Lake manage these data. About Edge Lake, tomorrow, Moshi and Nilog will explain more detail. And also, to sending data to the cloud and process data in the cloud, we will use ION Global Form technology, which is the NFS over ION All Photonics Network. All Photonics Network means directly to the each node connected by the optical network using several wavelengths. And also photonic disaggregated computer composable disaggregated infrastructure. If we resource need, just allocate the resources. And second use cases is storing data at the edge and also processing the data at the cloud using the green energies. We think there is some challenges for the green energies when the amount of the electricity generated by the solar or wind power exceeds the demands of the electricity. Power generation companies need to reduce the output from the solar and the wind power plants. This means throwing away all the green energy we have generated. As a result, the Kyushu region where I live in Japan lost approximately 1 billion kilowatts in the per year. This is equivalent to the about 10% of the electricity originally generated by the solar powers. So therefore, I think it is necessary to use the green energy more efficiently and reduce the ratio of the thermal power generations. So we think storing data at the edge and also processing data at the cloud using these green energy, which now we are throwing away, is a solution. So we put the data at the edge and processing data in the data centers, which area is where there is a surplus of the green energy. For example, when some data center is the night, we change the data center which process the data to the data center at where the data center on the evening, which is enough. There is enough green energy. So finally, I'd like to show you about scope of our joint POC. We are thinking about several phases about our POC. For the first phase one, we will feasibility studied about the NFS over RDMA over ION or photonics network plus edge link. Verify how fast ION can share the data to the cloud while managing data at the edge with the edge link. And also phase two, verification of the improvement by the composable disaggregated infrastructure, which is the hot-link disaggregated computing. Measure the time from the resource request to the resource allocations, and also measure resource efficiency by the things such as the composable. So the final phase is for features, actual application, for example, generative AI plus robotics, and also green energy use cases. Yeah. Here is the related information. If you are interested in, please access from this link. Thank you for listening. Okay. If you have any question and comment, so we have no time. Sorry. If you have any question and comment, please send me from the Slack channel or the some email is okay. Thank you.